So I've made a few improvements to my Python script. Um, if you don't know what I'm talking about, I'm gonna leave a link in the description below, linking to my other video in which I explained the tiny script in more detail. Um, Basically, I just added some features to my main script. These are the new features: convert one letter code to three letter code, convert three to one. These, of course, refer to amino acids, find k-mers in a given sequence, find the Jaccard similarity between two DNA sequences, and some restriction enzyme digest. Let's go through each of this pretty fast. First of all, let me just copy a DNA sequence from here and convert it to amino acids. Okay, so let's say this is my protein sequence right here, which is written in one letter code amino acids. I'm gonna go to main and let's convert this to three letter code. Pasting this. Right. So this is your sequence in three letter code. Let's just say I want to do the reverse here. Let's convert it to one letter code. And this is your one letter code. Right? Good. Let's go to main. Let's find some k-mers. First of all, let's copy a sequence. Here's the sequence. And next I have to input the length of the k-mer. Well, for demo purposes, let's just say I want to have 6 mers, so k-mers of 6. Here are all the k-mers for this sequence, all the possibilities for this sequence and this sequence alone. As you can see, they're sorted by the order of appearance in the sequence. So, for example, you have this 6-mer right here, and this 6-mer appears 8 times in the sequence. This one 7 times, this one 3 times, and so on. The rest of them appear just 1 time. Let's go to main, and let's do a Jaccard similarity between two sequences. So let's say, for example, let's copy a sequence from here. Let's just say this one. First of all, I'm gonna have to introduce the length of the k-mer. I'm gonna explain in a minute what this Jaccard similarity does in the script. Let's just say 20. Okay, so our k-mers will be 20 base pairs long. Let's copy the first sequence. Right, so this is the sequence. These are the k-mers for that sequence. Let's copy the second one, but let's make them somewhat similar. So let's say I'm gonna copy this with this region of similarity right here between the two. Copy this, type done. Okay. As you can see, we have a Jaccard similarity of 0.35. So what this basically tells us is the script analyzes the similarity between two sets. So firstly, we have the first set of k-mers in the first sequence and the second set in the second sequence. So by comparing those two sets, k-mer set 1 with k-mer set 2, it outputs a similarity between the two sequences. So what this tells us is that the sequences are 35% similar. So the Jaccard similarity is an index which is from 0 to 1, or in other words, from 0% to 100%. So this program tells us that the sequences are 35% similar, for example. Okay, let's go to main now and let's have a look at enzymes. So from this submenu, you can choose an enzyme from a set, or you can choose to insert the restriction site manually. Let's choose from an enzyme set. Here, as you can see, I only have 8 enzymes in my enzyme dictionary. However, I'm probably gonna add more. So let's copy paste the genetic code. Let's make it a big one this time. Say, for example, from here to here. I'm pasting this, I'm typing done, and then the program will prompt you to choose an enzyme you want to try. Input the corresponding number from 1 to what, whatever enzyme you want. So let's say we want to try on this enzyme, EcoR1, which has an index of 1. So I'm going to type the number. So I want to try enzyme number 1. And as you can see, it gives you the whole sequence, and it gives you the restriction sites for that particular enzyme. So here in this sequence, as we can see, the enzyme cuts 2 times, EcoR1 here and EcoR1 here. And these are the restriction sites. So we have here GA and ATTC, right? So this is the restriction site. We can also do this manually. What I mean by that is we're going to go to manually, and it gives you an example here. So I can introduce a restriction site manually. Let's see an example. So for example, this is the restriction site for EcoR1. But let's paste the genetic code. Let's paste this one. So this is the genetic code. I'm going to type done. And then I'm going to copy the left portion of the restriction site. So let's say we have an enzyme that cuts right here. So it cuts GA, it recognizes GA, makes a cut, and then it recognizes GAAA. So let's input this. So the left side of the cutting site is GA, and the right portion of the cutting site is GAAA, right? Let's type enter and see what we got. Okay, so as you can see, this hypothetical enzyme of ours, GAAA, cuts here, cuts in 1, 2, 3, 4, 5, 6, 7 places. Here's the restriction site that it recognizes. So we have GA, GAA, the same here, the same here, and here, and here. And so basically you can input any enzyme you choose. I chose the hypothetical one, but you can pick any enzyme that's not in the set, and it tells you exactly where it cuts. So yeah, let's quit this. This is my version 7.4, as I call it, on my Python script. As you can see, I did some noticeable improvements. One more thing I want to specify. For example, if we go to main, let me tell you something. For finding k-mers, so this particular code I copied from a YouTuber, from this one. So find k-mers. So yeah, the author is Next Gen Genomics from YouTube. So yeah, this is not my code. I just used his code, but I adapted it a bit to suit my needs. So yeah, so this is the tiny script I made and the update I made regarding it. Right.